Hi everyone, welcome back to my channel. On the board we have a JAMB 2006 question which reads, a shooter wants to fire a bullet in such a way that each horizontal ring is equal to 3 times its maximum height. The question says, at what angle should he fire the bullet to achieve this? And we have 4 options on the board for this particular question. But before answering this question, or before answering any question in physics or in any other subject area, it is important you ask yourself, which topic is this question gotten from? Now, this particular question on the board is gotten from projectile motion in physics. So before we attempt this question, I'm going to do a rundown for you of what projectile motion is in a simplified way. Now, what is projectile motion? A projectile motion is simply a motion of a body in which a body is thrown into a gravitational field and the body covers both horizontal motion and vertical motion. Now let me simplify that for you. Now let's say a boy decides to walk from his house, let's say this is house, to his school. So if the boy decides to walk from his house to his school on an horizontal plane, we will best tag this motion an horizontal motion. Just like you decide to walk from your house to your church, to a mosque, to your friend's house on an horizontal plane, that motion is best called an horizontal motion. Horizontal is just like you are sleeping. So on an horizontal or in a sleeping position, that motion is called an horizontal motion. Now, if I decide to take a ball and throw the ball upwards, the ball goes upwards and then returns downwards. So if I throw a ball upwards from the earth to a certain position, the ball goes up and then comes down. Now, a motion on a vertical plane is what we call vertical motion. Just like on a standing position. Then on a sleeping position is an horizontal motion. On a standing position is a vertical motion. So let's take a look at something. The boy walking from his house to his school, an horizontal motion, throwing a ball upward, a vertical motion. But in the case of a projectile motion, like I said, is a type of motion in which a body is thrown into a gravitational field, that is a region under the influence of gravity. And in the case of a projectile motion, it combines both horizontal motion and vertical motion. Let's take a look at this example. So if, for example, I throw a ball into space, the ball goes up and descends to the floor. So in this case, the ball travels from here to here. So in this case, the ball has traveled vertically. This is the vertical part of the motion. And the ball has also traveled from here. The ball was with me here. The ball traveled till it got to this point and landed here. The ball has traveled from here to here vertically. The ball has also traveled from here to this point horizontally. So if I take a marker and project it, the marker goes up to a certain height from my level of projection, which is the vertical plane of the motion, and ball will land at a certain point, which is the horizontal component of the motion. So a projectile motion is different from this other motion because a projectile motion is a combination of the horizontal motion and the vertical motion. Now, for a projectile motion, there are some things we should understand about the projectile motion. For a projectile motion, there are 2 different cases of a projectile motion, but we are going to stick with one in this particular video. So if I project a body with a particular velocity, an initial velocity, let's say u, at an angle to the horizontal, theta, mind you, you have an angle to the horizontal, which is theta. You can also have an angle to the vertical. But in solving questions in projectile motion, you are not interested in the angle to the vertical. Rather, you are interested in the angle to the horizontal. So for every question you solve in projectile motion, you are always going to use your angle to the horizontal to solve, not the angle to the vertical. So back to this illustration. We project a body, u. The body travels till it lands at the plane of projection. Now, 2 things you must note. The path, just like you have a bush path where you follow, the path through which a projectile motion follows is called a trajectory. The object I am projecting, let's say the object I'm projecting, let's say a ball for example, that object is called a projectile. While the motion itself is called a projectile motion. So the path through which this projectile will follow is called a trajectory. While the shape or the area under this path is called a parabola. Now, for a projectile motion, there are some formulas you must know when preparing for examination. Number one is this. If I project this body, remember with an initial velocity u at an angle theta, it will take this body a particular time to travel from here to this point, which we call the maximum height. The maximum height. The time it will take the body to travel from the point of projection to the maximum height is called the time to get to maximum height. So our first formula here, number one, is time to get to maximum height. And the formula for calculating this, or this guy is represented with small t. And the formula for calculating this is t is equal to u sine theta over g. So in your exam, you could be asked, particularly WAEC, what is time to get to maximum height? It is the time it takes the body to leave this point of projection to get to the maximum height. That is the time to get to maximum height. Number two, we have the time of flight, or the total time of flight. And this is represented with big T. Now, what's our total time of flight? The total time of flight is the time it takes the body to leave this point of projection, gets to the maximum height, and returns back to the point of projection. So the time it takes the body to travel or to fly, that's why we call it the time of flight. So this time of flight is represented with big T. Mind you, the time to get to maximum height is represented with what? Small t. So if it takes a body t to travel from here to here, let's say t, it will take the body t to fall back. So mind you, if it takes the body 2 seconds to get to this point, it will take the body 2 seconds to come down. So that means that our time of flight is equal to t plus t, and t plus 2 gives us 2t. So that means t is equal to 2t. Mind you, what is the formula for t? U sine theta over g. So that means that your time of flight, the formula for calculating the total time of flight is equal to 2u sine theta over g. So we have the total time of flight, then we have the time to get to maximum height. Moving on, the third formula is the formula for maximum height. What is maximum height? Maximum means the greatest. Height means a vertical distance. So putting that together, maximum height is the greatest vertical distance a projectile can attain from the point of projection. So it's very simple. If I project a body, the body can get up to this point. This is a vertical distance. The body can as well get up to this point. This is a vertical distance. But the highest a projectile, remember the projectile is the body or the object, can attain, the highest can get to from the plane of projection. It attains some several heights, but the highest is what we call the maximum height. And how to calculate maximum height? Maximum height, which is presented with h, is calculated with u squared sine squared theta over 2g, or some person can write it as h is equal to u squared sine squared theta simply means sine theta squared over 2g. So this is the formula for calculating maximum height. Last formula we have for this case of a projectile is called the formula for range. Now, what is range? Remember, we have height, vertical distance. So our horizontal distance a projectile can attain is what we call range. So range is the horizontal distance a projectile can attain, or we can say it's simply the distance from the point of projection to the point of landing. So that's range. So our formula for range, which is represented with arrow, is equal to u square sine 2 theta over g. The only part or the only formula that has 2g under as denominator is the formula for maximum height. So we have range, we also have what we call maximum range. So we can have what we call maximum range. So when we say maximum range, maximum again means the greatest. So range is simply an horizontal distance. Maximum range is the greatest horizontal distance a projectile can attain from the point of projection to the final point of landing. Now, a body will only attain maximum range when theta, you could be asked in exam, is equal to 45 degrees. So a body will attain maximum range when the angle of projection is equal to 45 degrees. Remember, your angle of projection is that angle to the horizontal and not to the vertical. So when your angle of projection is equal to 45, it changes this entire formula. So we have arrow max is equal to u square sine 2. Remember, in the case of maximum range, theta is 45 over g. Now, 2 times 45 is 90 degrees. Now, when we take the sine of 90, it will give us 1. So that changes this entire formula. Therefore, your formula for maximum range, which is arrow max, is equal to u square over g. So you have two formulas for calculating. You have the formula for calculating for maximum range, then you have the formula for calculating for just range. Let's come back to this particular question. From the question, what is important to us is that the horizontal range, not the maximum range, is equal to 3 times the maximum height. So from this particular statement, we can write it as arrow is equal to 3h. Now, mind you, your formula for range is u square sine 2 theta over g is equal to 3 times of the maximum height, which is u square sine square theta over 2g. So this is what we have from this particular statement. So from here, g can cancel out g on this side. Now u square on this side can take off u square on this side. So what do we have? We have sine 2 theta is equal to 3 sine square theta over 2. So when we cross multiply, we have it that 2 sine 2 theta is equal to 3 sine square theta. Moving on, we have gotten to this particular part of our solution. But before we solve this particular part, we need to have a good knowledge of a topic in mathematics called the trigonometric identity. Now, from that topic, we'll get to know that sine 2 theta is the same thing as 2 sine theta cos theta. Also, from that topic, tan is equal to sine, in this case, sine theta over cos theta. So, sine over cos will give us tan in mathematics. Also, in mathematics, sine square theta, that's for this particular part, is equal to sine theta times sine theta. So, just like say 2 times 2, it can be written as 2 squared. So we are going to use this knowledge of trig identity to solve this particular question. Now, coming back to this part of the question, we have 2. Now, sine 2 theta is what we have here. This sine 2 theta, just particular part, sine 2 theta is equal to 2 sine theta cos theta is equal to 3. Now, sine square theta is what we have down here. So sine square theta is equal to sine theta sine theta. So this becomes 3 sine theta sine theta. So when we open up this bracket, 2 times 2 gives us 4 sine theta cos theta is equal to 3 sine theta sine theta. So now sine theta can eliminate sine theta. So we have 4 cos theta is equal to 3 sine theta. So I want to make this expression to look like sine over cos. That means that I'll divide both sides by cos theta. Cos theta. So cos theta will cancel out cos theta. So what I now want to is now sine over cos so that I can make it to look like this particular expression. Also, I'll divide both sides by 3. 3 will cancel out 3. So what I now have on this side is now sine theta over cos theta. And mind you, sine theta over cos theta is equal to what? Tan theta. So this is tan theta is equal to, on this side of the expression, we have 4 over 3. And 4 over 3 is same thing as 1.33. So when we take the tan to the other side, we now have tan inverse. So it becomes tan inverse of 1.33. So when you take your calculator and press this, your theta is going to be 53.13 degree. So that's approximately equal to 53 degree. So answer to this JAMB 2006 question is 53 degree.